What happens when models like GPT and Claude move beyond chat and start diagnosing, recommending, and transforming patient care? Are we ready for foundational AI models to shape the future of healthcare? Welcome to another Tech Social, everyone. Thanks for being here. I'm Gabby. I'll be your host. Ajay Bell is joining us as a moderator, and the topic today is Beyond the Buzz, how foundational models are redefining AI capabilities in healthcare. Today, let me welcome Peter Walker as our speaker. Peter is the Deputy Branch Chief at the Defense Health Agency. He will have a chance to introduce himself in a bit. So thanks again for being here. If you have any questions, you can put them on the chat or you can raise your hand. We can take your questions like that as well. Yeah, let's dive in. Ajay, over to you for a brief intro, and then over to Peter for his background introduction.
Sure. Thanks, Gabby. Appreciate it. And Peter, again, it's an honor to have you here, and appreciate you taking the time off to talk with the team on, I think it's a very important area, especially with the growing concerns about AI and our data, our privacy, and how can we use AI to better effectively do a few things that we were talking about earlier, care plans, and then protect that data. So I'll let you go ahead, do your introduction, and then kind of prompt you on a couple questions as we go on.
Awesome. Thank you, AJ. And thank you, Gabby, for the invitation today. I'm looking forward to having an energized discussion on AI in healthcare. As was mentioned, I'm on my title there. I do want to kind of start out with an obligatory federal statement that the conversations I'm going to have today reflect my own views and not those of the federal government. But just a little bit about me. I'm an active duty data scientist in the Navy. My research is focused primarily on AI applications in healthcare. I got my PhD in 2005. Actually started to look at how at that time how I could sort of use my background as a cognitive science in the DoD, and over that time I've just been kind of an advocate and early adopter of AI and specifically the adoption within what we call the military healthcare system. So thanks again for having me.
Yeah, I'm just curious, what motivated you to kind of go into that area? Because it's sort of a unique area, right? You don't have a lot of people kind of going into that. So if you could share that with us, that'd be great.
Yeah, no, that's a great conversation. So when I was a graduate student in 1999, I actually started out in a PhD program in mathematics, but my undergraduate degree was in psychology, and then I started to take some very early classes in AI. And I realized one of my advisors that I still actually collaborate today. I've actually published several papers with Professor Ian Davidson at the University of California, Davis. We were talking at the time, and he was telling me, and these were some very, very survey level introductory to AI courses, how most of those AI models back in the early 2000s were modeled off of how they believe the human processes information. And what was interesting about that is because as somebody that also took a lot of classes in psychology, I had this epiphany that most of our models on human information processing, so there's models like Atkinson and Shiffrin's information processing model, those are actually based off of how we believe a machine processes information. So what you had two communities that weren't talking to each other, that were trying to build models off of what each other was doing. And so what we talked about, and really that was in, like I said, the early 2000s, how could we collaborate across two different kind of academic communities to try to really shape both of those? So that's kind of how I got into it. And then, as I was finishing graduate school, started to look in, kind of what I would do as either a postdoc or going into academia. My father was in the service, and it was always a big influence on me. And I thought, well, this would be a really interesting way to kind of take my knowledge, skills, and abilities and kind of give back to the federal government. And so made that decision in 2005, and have been really kind of both a sponsor. And what I mean by that is as somebody that has gone out to academic conferences, technical presentations, et cetera, and been again talking about as an advocate and early adopter for AI, but then also as a researcher. I'm still a PhD first and foremost, so still quite active on the publication front and trying to talk about how we can kind of revolutionize that. And so that's also what I'm excited to talk about today are some of those newer approaches that are ongoing.
Great. Yeah, that must have been quite, you were like the, I would say a trailblazer back then, because there was not a whole lot of stuff happening back in 2005. I mean, I can't even, imagine if there was even an AI model. And so the other thing that you said was kind of interesting that if you could expound on, it was a subset. It was two groups, and it was a subset. So whatever came out of that group at that point was kind of the evolving standard, regardless, right? So it's 100 people. That's what was, sort of built the model. Where today, I'm sure that's expanded. So you could probably maybe talk about that and how that's influenced your.
Yeah, for sure. And in fact, probably back then, we weren't really even calling them. I mean, there's certainly the field of AI, which we were talking about, but those are really just data science models, right? Most of those were actually, and I would talk, when I talk to people about what are some of the early models of AI, one of the very first early models that was widespread adopted was adopted by the US Postal Service and was just basically a neural network used to identify numbers, right, for zip codes. But those were not, as we think about AI models today, right, those were not the same thing. Those were just models designed to recognize computers, so computer vision models. But now what we've seen over time as the industry has grown and the academic fields have grown, much more diverse. And I would say that that's not just in AI. I mean, I think that's across all of science. What we've recognized is the need to be more diverse and inclusive in terms of how are we researching these ideas? How are we researching these topics? And it was an exciting time back then. Of course, we just had, the kind of the bubble burst in Silicon Valley that first around that time. And so what you had are a lot of those folks in the Valley coming back to academia and bringing those experiences in how we study this phenomenon.
Excellent. So one of the things I was going to have you talk about also is that, where do you see, some of the areas, because as you know, the whole AI engine, especially in healthcare, it becomes a very sensitive topic, right? And it becomes to a point where, okay, people are thinking, well, they're going to make all these decisions, and what are those decisions being based on, right? And how do we quantify those and use that properly? I think people I talk to will say AI will never work in healthcare. So because they're from that cloth that it's so vast. So how do you you get those, I'll call them naysayers, right? So how do you get them on that bandwagon?
Yeah, no, so that's a great comment. And what I would say is that, like any new field, right, there's for scientists out there, and we're going to hopefully have scientists from all different fields that kind of watch this and think about these kinds of problems. What I would say is like one of the most influential books in science was written by Thomas Kuhn, and he wrote something called The Structure of Scientific Revolutions. And what he talked about was that science kind of just plods its way along and, doing these very small, non kind of generational changes in science. And then there's a new technique, a new paradigm that'll come out, a new technology that'll come out, and that will change the way in which we view science. And when you're talking about AI and its adoption, specifically within medicine, it's been this kind of plodding along, right? Not really, we haven't seen these early adopters in AI in healthcare. But now, as you've seen things, especially in the area of generative AI, what you will see is that will be that kind of paradigmatic shift in the way Thomas Kuhn talks about it, that I will think you'll see this much more wider adoption. And I think that we can do that in multiple ways. I think what you need organizations like the federal government to also adopt these technologies with private industry. So if you just have one side, you don't have the other, you won't have that combination of what we call a requirements push, right? You have a requirement and people are trying to adopt it that way. And then you have a tech push. You have some new technologies going on that's pushing us to for a particular type of adoption. So I think that needs to happen. And I think the second thing that needs to happen is you need to see, we need to understand the difference between what I would call decision support tools, where you have a human what we call a human on the loop of the AI system. The human is not being replaced by the AI system. Rather, the human is an active participant with that AI system. So we're not trying to replace physicians. We're not trying to replace nurses. We're not trying to replace first responders. What we're trying to do is ease their workflow. So when we talk about AI and we talk about autonomy, we always talk about instances in which those are important. Those are important in instances in which we are talking about either the boring, the mundane, or the dangerous. And so if we can adopt AI with those types of ideas in mind, I think that's where you'll start to see much more wider adoption, both in industry and in federal government.
Okay, that makes sense. So where do you, so it's interesting because typically the federal government's been very slow at taking technology, putting it out there. And so what are you doing to make that adaptation much faster, right? And how can you bring that to useful? So like you said, it's not going to replace healthcare providers, clinicians, doctors, but in your opinion, how do we use that for the individual people? How can they start doing it? And what's the federal government doing about that? What's their stance on it?
Oh, no, it's a great question. So, and again, this out there is out there in open source for anybody that's interested, but you're seeing a lot of work coming out of the Pentagon. So typically within the DoD and the federal government at large, right, we have very, very long adoption processes. So when we want to bring something to an actual capability to our systems of record, those can take oftentimes many, many months or even years for adoption. And what we're seeing now is that we need to mirror private industry in terms of the way in which we adopt them. So, things like agile software development. So what we've done in the federal government is start to adopt those types of frameworks. In fact, I just wrote a paper that came out in the past year, basically talking about what we call an agility readiness level, right? How is the organization prepared to work with a developer where their requirements might change? Again, in the federal government, when we're trying to build something, we're trying to build a widget, we're usually, if we're going to build an aircraft, for example, we're going to have those requirements for years upon years, right? That's going to be deployed for decades. When we're talking about softwares, we don't need that type of life cycle. What we need is to be able to prepare it or to develop it, deploy it, and then as those requirements change, work with those developers so that we can change it kind of online or in real time. So I think we're seeing a lot of work coming out in the federal government to change what we call our acquisition life cycles or our acquisition adoption for AI and software. And I think that is a very, very positive movement in the right direction to ensure that we can be early adopters, not late adopters.
Yeah, that makes sense. And I'm just curious, you've got all of these different kinds of healthcare portals. You've got Medicaid, Medicare, you've got state, the Obama plans. Is that part of the plan for the government to be able to consolidate that, take those data and start to use that for, for the constituent, for us, the people, right?
Sure,
Is that
absolutely.
on there?
Yeah, and I don't think that I'm knowledgeable enough in terms of what a kind of broader federal strategic initiative might be. But what I can say is that we are starting to see a lot of groundbreaking work that allows us to have the infrastructure so that we can do that, right? I think before we talk about widespread adoption of, let's say an omnibus electronic health record, an omnibus EHR, the only way in which we're going to do that is if the infrastructure is there that allows us to do that. So that means some type of data environment that exists that we can then share. And so I think that is those are being developed. You mentioned things like PII and PHI. So even though we might have military service members on one electronic health system, and then we might have VA service members or even, let's say, service members' dependents on a different healthcare system, right? How do we share that data? It's one thing to be able to share that data. So, of course, privacy, HIPAA, all of those things are very, very important when we talk about sharing data. But we need to be able to share the data so that we can actually move toward, again, the topic of today's discussion, foundational models, right? The only way that we're going to be able to do that is to make use of all of that data. So again, I can't talk about this a broader strategy because I simply don't know. But what I can say is the infrastructure and the technology is leaning in that direction so that we can start to have more sharing of resources. In fact, and we are already seeing that, especially on the private side.
Yeah, that's great. I was talking to a gentleman who's actually doing what they call a digital twin. I don't know if
Yep.
you've heard that
Yep,
before,
very
right?
familiar.
Where you're taking dissimilar systems. Let's just say your healthcare. Now you go from United Healthcare to over to Aetna or Blue Cross Blue Shield. The challenge becomes your data doesn't follow you necessarily. He was explaining me this, and so he goes like, "We got to produce this digital thing. So then tie it with Epic and all of the leading,
Yep.
ER systems." That in itself seemed like a pretty big task, right?
Yep. Yep.
So can you speak on that? What's the government
sure.
looking at
Yeah.
doing that?
Yeah. And so, what I do first is go back to what you talked about in terms of, where can we adopt AI, right? So it's one thing to say that we want to create a digital twin for somebody's EHR, right? That is very difficult to do, and also we're going to see resistance, potentially within the federal government for things like FDA, right? Is that a medical device, or is that actually a tool that we're going to use for diagnosis and even treatment recommendations? So some of the things that we're trying to do to use it as a sandbox to test the capabilities and to and understand what the boundary conditions are for those adoptions. So we're actually developing digital twins as well within our healthcare networks. But what we're doing it on is the financial side. So being able to do things like looking at claims data, looking at how a patient is moving within and outside of our healthcare system within the federal government to private industry. So let's say person X, patient Smith gets a referral outside of our network into a private healthcare system. Can we then track that patient and then develop models that might look at how is patient satisfaction doing, or to what extent are we likely to see that patient come back to within our network, or once we've lost them outside of our network, are they going to stay outside of that network forever? And so what we're trying to do is develop those digital twin technologies that you just mentioned, but doing it on the financial tracking side, because that serves as a proxy. If we can do it there, then we can start to think about the boundary conditions. We said we've taken a couple steps outside of our comfort zone. Now, are our leaders comfortable with that? Are they happy with that? If they are, now let's take a couple more steps. Let's take a couple more steps, and we can start to really test the system, what our appetite is for its adoption by taking that kind of approach.
Yeah. So it sounds like, from your point, there's a lot of challenges still with the public AI healthcare system. What do you think the biggest 2 or 3 are right now, that you see coming up all the time,
Yeah, I think it comes down to 2, and I think the first is compliance, right? I think that we have regulations for medical device adoption, and those are in place for a reason, right? We have to ensure that they are safe, right? We have to ensure that any rollout of said systems are going to be democratized. It's not good for a healthcare system if we're only able to provide those resources to the people that can afford it or that have access to it. So how do we democratize those? That's a part of the quote unquote regulation. So I think that's one. I think the second one, which is more of a cultural issue, is its adoption. And so what we need to start doing is very early on, and I think we're starting to see this in medical schools across the country, exposing the next generation of providers as early as possible to these technologies, right? And by exposing to them, you'll start to see that they can integrate that into their workflow. What we're not doing is asking the doctor tomorrow to use an LLM to help diagnose a patient. But what we might be doing is saying, hey, how about using an ambient dictation tool rather than just doing handwritten notes for your patients that you saw today? How about dictating that to another outside tool and allowing that to kind of generate a patient summary, et cetera? And I think, again, taking that metaphor that I used before by understanding what those boundary conditions is, taking a couple steps off, I think that's what you're going to start to see the adoption phase really start to ramp up on the provider side as well.
That's great. So one of the things I I think would be interesting to get from your point is people that are in, students or younger guys that are in the field today, what would you recommend? You know what I mean?
Yeah.
So when they come out, they're more marketable, to be frank with you, right? Because that's, I'm like you, old school. I graduated computer science back in like 1988, right? And then all of a sudden, all of that kind of went out, right? It was all COBOL, it was all the different things. So today it's a completely different environment. So I would like for you to talk about what do you see that we can actually take away, younger students, those kinds of things, to be better equipped for AI for the future.
Yeah, there was a really, really great paper that was written by one of my former bosses. And this is written really around 2012, 2013, but he was really looking ahead. And what he said was, in this case, again, he was talking about sailors and Marines of the future. And what he said was that we should not be trying to recruit, we should not be trying to train people that are going to be writing command line code. Because he said the sailor of the future is not going to be, writing code for an AI system. What they're going to have to do is understand how the AI system works and query that system so the systems can almost manage and take care of itself. Again, that human on the loop that I mentioned before. And so what I think like what we need to do is how do we create this next generation of scientists that understand what we would call things like prompt generation? Because that's really what this individual was talking about. He was talking about knowledge work. He called it knowledge workers, but he's really talking about prompts, right? How do you ask the right prompt? I mean, we can get everybody on this call today, and we could ask them to generate some code using an LLM, but they may ask that in a number of different ways. And so I think, understanding what are the right ways, what are the good habits to get into, what are the bad habits to get, that we can get into in terms of interacting with those types of tools, I think is really, really important for this kind of next generation of scientists. Certainly one of the other things that we need to do, whether we're talking about our federal government or really just society as a whole, is we have to support STEM, right? Science, technology, engineering, and mathematics. Our skill set in this is we are going to get outpaced by our LLMs. In other words, our LLMs, of course, they're getting smarter and smarter every day because we're finding more and more labeled data that we can train them on. If we're not keeping up in terms of our ability to develop new algorithms that can keep up with the existent data, we will lag behind. And so I think investments in science, technology, engineering, mathematics are quite critical here.
Yeah, I would tend to agree. And to be frank with you, I think the US is falling behind on those areas, which is bad because then we have to go outside of the country to go get that talent. And yeah, I don't know what the answer is to that. I don't know how to, get people more into the math and the sciences, like you said, because it's a problem, actually.
For sure. For sure. And I think, I think like, it's one thing, to talk about how do we encourage more people to take that on as a major as an undergraduate. But I would argue that that's too late. That if that person is thinking about it when they're an 18 or 19-year-old enrolled in their first year of college, it's already too late. We need to encourage them early on, right? So how do we introduce more STEM into, primary school? How do we introduce more STEM, as people are, entering middle school and high school? And I think what you'll start to see is they'll start to develop more affinity toward that at those ages. My son actually started coding in something called Lua for Minecraft really at the age of 8. And what you'd be surprised because even though it may be just really a language that's specific to for developing environments there, what he's actually learning are basic coding concepts. So he's learning things like how to write for loops, right? How to, how to make calls to libraries. All of those kind of knowledge, skills, and abilities that we take for granted as developers, they're learning that at a younger age. So, how do you incentivize people? And it needs to be, I think you need to create intrinsic motivators, right? What you can't do is you can't extrinsically motivate somebody at that age by saying, hey, you're going to make a lot of money when you graduate college if you major in one of these fields, right? You have to intrinsically motivate them.
Yeah, no, that's a good point. Go ahead,
Sorry.
Gabby.
What about psychology? Because I think some of the biggest advances are happening also at the intersection of psychology and AI.
Yeah.
So how do you see like cognitive science influencing the way we build or the way we evaluate AI in healthcare?
Yeah, no, those are some great. That's a fantastic thing. In fact, I mentioned our lab and some of the things that we're looking at right now. So, again, when we talk about the very first neural network model, right? We have an input layer. Even the very first neural networks, right? We have some kind of hidden layer, which most of us don't, or most people don't really necessarily try to explain, and we have some kind of output layer, and that was used to kind of explain, like kind of the if-then kind of outputs. The problem with or the metaphor that was used to design those very first neural networks were how the brain processes information, right? That neuron, right? You have a neuron fires in the brain, that neuron then activates, and then there's some spreading activation that moves from that neuron to another neuron, and then we ultimately have some type of concept that's being realized in the brain. What we realized was that was a very limited model in terms of how the brain processes information. And so you started to see some influence in cognitive science. And so that's when we started in 2012. You had work like ImageNet, et cetera, where we had more data. In fact, I'll just take a real quick take a step back, right? The emergence of AI happened in my opinion, for three big reasons, right? One was that you had increases in computational power because of the development of GPUs, right? That we could use GPU processors that we typically use for video games. We could use them for machine learning. The second thing that was we had also we had a realization that we needed labeled data. So ImageNet was a kind of a epiphenomenal moment for the community. We had thousands and thousands of labeled images that we could train models on. And what that allowed us to do was to develop different kinds of models. And so led to the development of the first deep neural network, right? And the deep neural network was actually how we think the brain, the brain, trillions and trillions of neurons. But I would say if we stop there, that we are limiting ourselves. So you mentioned cognitive science, right? I did my dissertation on basically something called reentrant processing. And so the idea is that the brain just does not do either top-down processing or bottom-up processing, that we also see a lot of this kind of what we call reentrant processing, that some type of image might project forward into more advanced regions of the brain, but as those regions of the brain are processing information, that information will then flow back to more primitive areas of the brain, and we'll try to then make sense of what's going on. And so what I've argued to several of my different collaborators is, can we build those types of architectures into either neural networks, deep learning systems, so a reentrant processing. So there is something called recurrent processing that goes on. We saw a lot of work in what's called LTSM, long-term, short-term memory storage in deep neural networks. So we're starting to see a lot more influence in the AI literature from cognitive psychology, cognitive science, et cetera. The last one I'll leave you with, which I think people probably haven't heard about a lot right now, but I think this will become one of those household terms in the next few months, because we're going to see a lot of work in this, is what we call metacognition. So the idea of thinking about thinking, right? And so what we're trying to do is develop models, especially on the LLM side, of getting the system to think about what it's doing. And why would we do that? Because it can certainly lead to more reliable, more trustworthy data. It also leads to explainability. If we were just to ask the average GPT user, why did it get to a certain output? They don't understand that. But we need explainability in those algorithms. And so building in things like a metacognitive component will help with explainability as well. So just to kind of finish off that thought, is you are starting to see, and not just in the psychology, but you're starting to see a lot of work in linguistics and how linguistics can influence our AI development, especially LLMs. We're starting to see a lot of work, again, from things like optometry, et cetera. How do those effects on multimodal AI systems, et cetera? So, but it's a great question.
No, thank
along
you.
that path, it's kind of interesting that, the cognitive development and what Gabby brought up. As the population starts to age more, right, you've got different levels of memory, right? And I've dealt with people with, quite frankly, Alzheimer's. Where do you see AI trying to help maybe, diagnose some of those things, or
Sure.
the research that we can use to treat people like that, or maybe one day even figure out what's causing all of these things, right? So I'd be interested in your view on
For
that.
sure. So again, the title of today's talk was foundational models and how they're redefining AI, right? So what you could certainly see is that we're starting to see a lot more interest in developing imaging data banks, right? I mentioned ImageNet before. In 2013, Fei-Fei Li developed that, which was just thousands of Google images that were on the web, and then we had human annotators labeling those. Imagine us being able to do the same thing with somebody suffering from early stages of Alzheimer or early dementia, right? So we could take brain scans, MRIs, fMRIs, and we could have people label those. We could also take, tests in cognitive ability and EHR. So the way those foundational models for things like dementia and other forms of pathology, the way that we're going to get to foundational models is start to create those open source labeled data sets, and then allowing the research community then to data mine those communities to start developing models and improve upon those models over time.
Yeah, no, that makes sense. Yeah. I think that's great. Is the government involved in those initiatives? Are they, getting funding
Yep.
for those types of
So,
initiatives?
so, so there are. So, a lot of work that was being done both at NSF, and you see things like NIH, and as well as on the DoD side as well. For us, on the DoD side, some of the things that we've looked at is we're obviously interested in kind of more injury. So you might see an injured individual, and so one of the things we're looking at is like, are they injured from a single acute event? Are they injured from repeated exposures to a certain traumatic event? Could that then lead to pathology downstream? So those are some of the things that we're looking at. There are a number of different published open source data sets that for folks that are interested on the research side to look at. So there's something called AFNI, which is the I forget what the A is, but Automated Functional Neuroimaging Initiative, I think. It's AFNI. So that was initially published, which was just a large corpus of labeled EHR and imaging data sets. What is also available on to look at some of those kinds of things is also something called AFNI DoD, which looks at DoD patients and providing those same labeled data sets for researchers to try to look at, to try to move toward developing some of those foundational models. What I would say is that there are a lot of disparate data sets. What we don't have is something that is as big a grand challenge that we saw with ImageNet, and that's what we need to get to actually develop some of these foundational approaches.
Do you feel that the other countries are farther ahead than we are in these areas because they focus more on this, or they
Yeah, that's a great
fund
question.
more?
Yeah. I don't know, because I feel like in terms of in terms of the research literature, I feel like it's very collaborative in nature. I collaborate with folks not just inside the U.S. but outside the U.S. as well. I would say within the U.S., in terms of our investment approach, I think we're very strategic in the way we've approached it, and I think that we're going about it the right way. That's again, as I mentioned to start this, that's my personal opinion. I do think that we're going about it the right way. I just think that these are very, very difficult problems. I don't think that these are,
Yeah.
to somebody to think that we can just, turn this switch on and we're going to solve it in the next 2 years. That's just simply not, that's not true. I think LLMs have demonstrated a tremendous amount of power, generative AI, but that doesn't mean that we still don't have to have, that still doesn't have to be based upon good science, right? And so it's a combination of how do we leverage those tools, and then also how do we get the real leaders in those fields to also to challenge these problems.
Right. Yeah, that's a good point.
So, Peter, I have one more question. You've been telling us that you have worked across both like defense and healthcare.
Mhm.
Are there like any lessons from the military approach to AI and innovation that healthcare can adopt or avoid?
Great question. I think we kind of hinted at this before. I think the one thing that we would that we would ask. So I work on the small business side as well, and I always talk about dual use, and I think that that's really, really important for industry to adopt. Is maybe not think about when they're talking about solutions, not try to restrict it to a single pipeline solution, right? But rather, how that could be, how we could develop kind of other pillars in which a certain technology or a certain algorithm, a certain solution might be used. Uh, uh, so as an example, one of the things that we're starting to look at is looking at drone technology and how that might be used to support things like logistics, right? For us, we have, huge logistical tails. And so the question might be, how can we adopt things from something like, I use the metaphor of something like DoorDash or something like maybe Open Table, right? Where we're using kind of more networked approaches to deliver things. And so what I would say there is like, what I think we need to get out of are these kind of stovepipe solutions, right? That we're developing a solution for X and that's all it can be used for. How can we take a solution and then modify that for a different type of, a different area, a different paradigm?
Got it. Right. And this takes me to my next question, which I wanted to know your opinion of, because there is like an increasing interest, in small, like domain specific models versus like giant general purposes ones. So do you think the future would be like a hybrid models,
For
or
sure.
we will continue to rely on the giants?
Yeah, no, I don't think so. I think it is this hybrid for sure. And I think a great example of that we started to see on the computer science side was that we saw as we were seeing a lot of work on these large kind of foundational approaches, generative AI, et cetera, we were still seeing a lot of investments on much smaller, kind of finer tuned models. So things like zero-shot learning and few-shot learning, et cetera. And in fact, everybody's paid attention, right? One of the generative AI models that's become very popular in the last few months is DeepSeek. And the reason it's popular is because it requires less data, right? It requires less fine tuning. And so I think like what we can't, and that goes back to my point earlier, right? If we just focus on trying to develop models on one side and ignore the other, we're going to miss something. And so I think by like, let's, we as researchers, we can't be specialists in everything, right? You can't be that jack of all trades, a master of everything. But, how do you specialize in one area and at the same time make sure that that other area is not lagging behind, that they're also, seeing those same types of incremental gains?
Right. I have one more question on my side. What would be like one use case for foundational AI in healthcare that you think will be fully realized in the next 2 years? And will it make like a real measurable difference in people's life?
Yes. So there's a lot of work coming out of the DoD, and I was very excited to be a part of this. And this is a great partnership with industry as well. We developed what's something called the augmented reality microscope. Essentially, the DoD has something called the Armed Forces Pathology Center, where we basically collect lab samples from service members, and those were just essentially sitting in warehouses. And what we realized is that we could use that data to actually start to train algorithms to start to do things like identify pathology. In this case, what we were trying to do is identify potentially either precancerous or cancerous cells. And so what we actually did was we invested and worked with private industry to actually start to train models to start to look at those types of things. And what we then did, it's not enough to develop the algorithm, right? What's the next step to that? The next step then is to then start to do things like, well, how then do we deploy that on some type of capability? So as part of this, the DoD partnered with something called the Defense Innovation Unit, where we actually then started to develop something called an augmented reality microscope. So this is where a pathologist can now look under a microscope, actually look at those slides, and the microscope now is working with the algorithm to identify regions of interest, right? And say, hey, have you paid attention to this area? This area might be an area that we should be focusing on. And so again, that's kind of in this early stage of adoption. What I think will happen within the next few years, we'll start to see some major breakthroughs, and that's going to impact thousands and hundreds of thousands of lives with because now we are going to be able to be more sensitive, more we can have pathologies that are more detectable that might not otherwise have been seen by just the naked human unaided eye by using AI. But again, we have a trained pathologist working with the algorithm. Again, the algorithm is not replacing the human. The human is working with the algorithm. That's a great question.
And I'm curious now to know what was your day like back then when you were doing this or you were participating in this project? Like how many other professionals were there to implement such a great tool?
Yeah, that's a really funny question. I always go back to this one story I thought was really funny. So we were make sure I don't get myself in trouble here, but we were developing some algorithms to try to predict essentially where we might see IEDs, improvised explosive devices. And it was me and one of my collaborators. I mentioned Professor Ian Davidson. And I remember we were going to presenting at a conference, and we had this. So we had developed this poster, and we had our slides and everything, and we're at the airport and we're talking about this. So you can imagine we have two researchers talking about developing algorithms to predict where we're going to see IED. We had this data that we were mining, et cetera. But think about where we're at the airport and talking about bombs. And so it's like this was probably not something that would have been, that looking back on that we should have done. But we were so excited, so energized because we're really trying to develop a new capability that not a lot of people were really interested in. So I think that was one interesting thing to look back on. I think another interesting thing to look back on was probably around 2018. Again, you can say AI and everybody knows what you're talking about today. In 2018, that was not a household term. I used to joke around that people couldn't spell AI in 2018, right? AI. But so we at the time we were looking at, well, how do we start? This goes back to something AJ was mentioned, right? Within the federal government, how can we invest in this, right? I was serving as a program officer at the time. What that means is we're essentially an investor on the behalf of DoD. We write grants, contracts with industry, grants with universities. And so we were trying to start this program. And it was so exciting because what we're trying to do is talk to universities and saying, how do we develop a program in this space that would incentivize you as a university to look at the kinds of topics that we're interested in the DoD, but at the same time, making sure that the IP, I don't mean in a commercial sense, but in terms of an academic sense, how is your intellectual property then back so that it comes back to the federal government so that we can use it, so that we can start to adopt that technology. So I think it was just a really, really exciting time in 2018, being one of those early investors in AI technology. At the time, I wasn't even working in healthcare. I was actually working in something called manpower, personnel, and training. How could we use it to develop more efficient training systems within the federal government? How can we use it to develop more recruiting, better recruiting strategies, et cetera? But yeah, those are two things that I look back on them, and I just I kind of laugh about it. That it was fun to be a part of.
Definitely.
I got a question for you. How is the federal government going to attract talent to be able to work on these things, right? I mean, I've seen a lot of the people that come and they want to go into the private sector because obviously money reasons. So what are you folks going to do, what's incentives? You follow what I'm saying, Peter? What do you
absolutely.
give these guys?
Yeah, and that is, I mean, probably of all the questions talked about, that's probably the most important from my perspective anyways. I think first and foremost that, I mean, ideally we're trying to recruit people that are what we would call in love with the mission, right? And that doesn't have to be at the DoD, right? Like for NSF and NIH, right? Somebody that is in love with sponsoring early science and technology, right? That is in love with the science, right? So I think that would be, that's kind of one. Now that only goes so far, right? Someday I'm going to have to hang up my uniform and go do something else, right? I'm looking forward to the opportunity to potentially make a little bit more than what I'm making right now in the federal government, right? Has to start there. That goes back to what I said before. There has to be some intrinsic motivator, and the intrinsic motivator there, hopefully, is that hey, there is something bigger than yourself that you want to be a part of, right? And that's supporting the federal government. But I think once we look past that, there are some other things that we can do, right? I think the other thing, I mentioned some of the projects that I've been involved with, right? Very rarely is somebody in basic science or somebody in industry going to be able to have the same types of opportunities that somebody on the federal government have. I'll talk about something that I've had the opportunity to do, but then I'll talk about some things that other people have been able to do. I've had the opportunity to go fly on, to fly on an aircraft carrier, to do takeoffs and landings on an F-18 and a T-45. As a data scientist, I don't know of anybody that I've worked with that I've published with, et cetera, that has had those kinds of opportunities, right? That was we used to joke around. This is just a joke. Don't get me in trouble. Report me to some IG. But that was the most fun you could have with taxpayer money, being able to take off and land on an aircraft carrier with that. But even scientists, like that were not working in those operational volumes. So like for us on the Navy, we have things called like programs called Scientist at Sea, and that's where a scientist can go, participate in an exercise or go, on an aircraft carrier or go on a cruiser and look at what life is like on sea. So I think the exposure to other types of environments, if you will, for lack of a better term, right? I think that is something that a lot of scientists, right, would appeal to them to be able to kind of be a part of that firsthand, rather than just writing command line code. Being able to see that and understand where your technology is going and how that is going to impact lives, I think is and again, I'm talking about it from a DoD perspective, but I think the same opportunities exist at NSF, the same opportunities exist at NIH, the same opportunities exist at BARDA, et cetera. And so I think that's what the way in which we'll also be able to continue to recruit first-class talent within the federal government.
Yeah, I was just thinking about all of this stuff going to Mars and all this, or how they're sending the scientists now. That's like another area, because that's helping science, right? Those kinds of things. So, so I'm curious, were you ever like deployed into an area that was like a war zone area, just like the stuff? Just curious. You don't have to bring up.
So what I would say is that, like, you should never agree to become a quote unquote, or even any kind of federal employee if that is not something that you're not comfortable doing. Now, I have not actually deployed. What I have been in for deployed settings, but I've not formally deployed. I've been, for example, in the Indo-PACOM region, right? I've been in Europe, et cetera. I've volunteered several times to do that. Sometimes it's very difficult, right? If you're viewed as having a particular skill set, it's should they send person X or should they send somebody else, right? So sometimes, even though you may have the right knowledge, skills, and abilities to do that, there may be somebody else that's better suited or more needed for that situation. So to answer your question, no, I've not actually deployed. I've been in for deployed settings, but not in what we would call a formal deployment.
Got it. Okay, great. Well, we're almost bumping up against an hour. Do you want to open it up, Gabby, for questions then for Peter?
Yeah, sure. If anyone has any questions, please go ahead and put it on the chat. I do want to ask you something, Peter. We talked recently about what governments can do to attract the right talent, right? But now my question to you is, what should someone do if they want to follow a similar path than you did? Where to start? Is it too late?
Yeah.
Because obviously you have a lot of, your background is huge, but like any, tips, any resources, even if you have them that we can go to and read and learn, understand, etc.
Sure. So great. I'll start with kind of thinking about it this in terms of being at three kind of points in your kind of career or education, right? For somebody that's kind of pre-degree, right? So either if you're in let's say high school, you're in an undergraduate, et cetera, there are a lot of internships that are offered within the federal government. And again, I know that I've been talking from my perspective at the DoD, but that exists for other agencies as well, right? So look for those opportunities to do internships, because then you will see firsthand in terms of what actually goes on in those jobs, and you can make that decision for yourself. Is this something that I want to do? Or is this not something that I want to do, right? if you're in that post degree kind of area where you've been out of school for a bit, right? Then what I would recommend is going out and trying to find somebody through, you mentioned LinkedIn, right? That's how, Gabby, you and I connected, right? Is through LinkedIn, right? It is there for a reason. Connect with those people and ask questions, right? What is your job like? How did you get involved? Do you have people that I could potentially talk to, et cetera? And then kind of to your last point, is it too late? What I would say is that, in my opinion, it's never too late to serve. And the reason why I would say that is there's more than one way to serve. I serve as a uniform data scientist, but you can serve as a federal civilian. You can serve as a contractor. You can serve as somebody developing a capability that the federal government needs. Let's not think of service as just somebody that is actually formally an employee of the federal government. If you're developing something that we need, we want to collaborate with you. We want to hear from you. And so reach out to those people, tell us what you're working on, how can we get involved, et cetera. I think that's kind of would be my final point there.
Thank you so much. Great input, Peter. Okay, so I don't see any comments on the chat. So I guess we asked so many questions to you already. Yeah, I think we can start wrapping up. Ajay, do you have any closing comments? If not, Peter, do you have anything else to say before we wrap up?
I just want to thank Peter. I mean, this has been really insightful because we all, I do a lot of stuff with the public sector, right, or private sector, nothing in the public sector. So I think you kind of opened up our eyes in terms of what's happening in the federal government, where normal people don't realize how much you guys are advancing in sciences and also embracing the AI technology. So thank you for that. And thank you for your service too, by the way. Appreciate that.
Thank you. Yes, the last thing that I want to leave is just kind of a Chinese metaphor for everybody, right? No talk's complete without one, right? But so when is the best time to plant a tree, right? Best time was 20 years ago, but the second best time is today, right? Or now, right? And so what do we mean by that, right? Like if you're somebody that's wanting to get involved and you were not somebody that's formally trained, look for resources to get involved. Look for get on GitHub, get on Leak Coders, take some classes on Coursera, et cetera, right? Educate yourself and be a part of that growing community. I think this community is not exclusive by any means. It's very, very inclusive. And I think that's how the community, in terms of a research area, is going to grow and advance, is because we get people with different views. We get people with different ideas. So again, thanks again. Really excited to kind of keep track of how the blog is going.
Definitely, Peter. Thank you so much. I believe Ajay and you connected already on LinkedIn. So I'm going to extend one more time the invitation. If you ever happen to be in Michigan, you're more than welcome to these events they do on Wednesdays, Chai and Business.
Sure.
Yeah, thank you so much. We'll keep in touch. And thank you, Ajay, and everyone else. See you next Thursday for another.
Thanks, Peter. Take care.
Thank you. Bye-bye.
Thank you so much, everyone. Bye-bye.